Hello everyone, welcome to video lecture of Advanced Manufacturing Technology. I am Manu Joseph, Assistant Professor, Department of Mechanical Engineering, Rajagiri School of Engineering and Technology. Today we are going to discuss about Material Addition Process Part 1. This is a part of 6th module. In this lecture, the topic we are going to cover the introduction about rapid prototyping, type of rapid prototyping, stereolithography, fused deposition modeling, selective laser sintering, laminated object manufacturing. So, rapid prototyping. As an introduction, new generation manufacturing, both manufacturers and customers has less patience to wait for their components. One of the modern business requirement is that the traditional processing time need to be shortened. We need our product as early as possible. This can be accomplished by reducing the time required for each phases of the manufacturing. Here comes the importance of rapid prototyping. Suppose we want to produce a part through casting. It involves number of phases for preparation of mold, preparation of the material, pouring of the molten metal, solidification, finishing operation, etc. So, molding itself is a huge process, preparation of the pattern. If you could reduce the time of preparation of the pattern, we can reduce the total time for casting process. So, through rapid prototyping, we can prepare this pattern within a short time, thereby reducing the time for particular phase of the manufacturing. So, rapid prototyping, in simple way, it can be defined as is rapid physical modeling of a design. It's a rapid physical modeling of a design using specialized manufacturing technique. Or rapid prototyping enables to manufacture model and prototype or model or prototype quickly from model data. The model data can be a CAD model, that's a computer model. So, rapid prototyping is an additive process. It's always additive, not subtractive. Additive process. Add material in layering process. It's in layers to create desired form, thus enabling complex form to be manufactured in one piece that would otherwise be impossible. So, manufacturing a single piece is very difficult. We need to make the entire setup for that. But through rapid prototyping, the manufacturing of one piece become easy. The rapid prototyping is also known as solid free form fabrication. Builds complex shape through additive process. As I said, it's an additive process. Producing component without use of tool. Here we are not using this. One of the speciality of rapid prototyping. Here we are not using tool. It's an additive process. So, this is a comparison between conventional machining and rapid prototyping. The conventional machining and rapid prototyping. In conventional machine, produce model by removing material bit by bit. But in rapid prototyping, produce model by adding material layer by layer. This is an additive process. This is a subtractive process. Remove material in the form of chip. This is a subtraction process, and this is an addition process. Why rapid prototyping? What is the importance of rapid prototyping? What are the advantages of rapid prototyping or application of rapid prototyping? The physical model of part can be manufactured in a matter of hours and allow rapid evaluation of manufacturability and design effectiveness. Suppose we have a design, we prepare a design for a particular project. We need to evaluate its effectiveness. For that, manufacturing the entire component as such is impossible or difficult. So, rapid prototyping enables us to rapid evaluation of manufacturability. The rapid prototyping serves as an important tool for visualization of concept verification. This help the user in knowing how the final product will looks like. The rapid prototyping is an important tool for visualization of concept. Suppose we have a concept, we want to visualize it, we want to see it, how it looks like. We can use rapid prototyping technique to prepare a small model. Okay. As the development costs are reduced, rapid prototyping proves to be cost effective. It's a cost effective technique. It's easier to find design flaws in early developmental stages. That is also one of the advantages of rapid prototyping. There is better communication between the user and designer as the requirement and the expectation are expressed in beginning itself. So, the designer or the user give certain suggestion. Designer design it based on user's suggestion. After designing, the user make a small model using rapid prototyping. It's a cheap one, and he can communicate that with his user, so that whether his idea, the user's idea, is matching with designer's idea. High quality product is easily delivered by way of rapid prototyping. The process itself reduces waste as unused material can be recycled. This represents the steps involved in rapid prototyping. First, we have a CAD model. We start with CAD model. We have a design CAD model. Then we pre-process it. So we will convert this CAD model to an STL file. It's a STL file. STL file means standard triangulated language file. Here the images get converted to small triangles, that is STL file. Then also it builds supports. The supports certain structures. When manufacturing, it won't have the enough strength while manufacturing to sustain. For that we will give supports for that. Temporary supports. It can be removed in later stages. Okay, so that is, we are building supports if needed. Then slicing. So big component we cut it to layers. As I said, this rapid prototyping is layer by layer manufacturing. Is additive layer by layer manufacturing. We are slicing the entire component into small layers. So then the rapid prototyping or build prototype using suitable technique. Then we will have a post process, remove support, clean surface, post curing, we will heat it or cure it once again. So part is completed. Okay, these are the steps in rapid prototyping. Steps I have written once again. So convert to STL format, that is standard triangulated language. This standard triangulated language is easy to store. If it is in the CAD drawing is in standard triangulated language, is easy to store or convert. Since STL file, slice the STL file into thin cross-sectional layers, that is layering process, or slicing process. Construct the model one layer above the another because it's an additive process. So first layer is created, this is the first layer. Over that we have the second layer, then third layer. It's an additive process, layer by layer. Clean and finish the model. The final stage, clean and finish the model. The type of rapid prototyping: liquid based model, solid based, powder based. In liquid based, rapid prototyping system has initial form of its material in liquid state. So stereo lithography apparatus falls into this category. Initial state is liquid state. We start with liquid state. Solid based rapid prototyping system encompass all forms of material in solid state. Solid form can include shape in the form of wire. It can be wire, it can be roll, laminates, pellets or powders. So this powder based system, it also comes under solid based. That is solid based rapid prototyping system. Selective laser sintering, here it is powder form. 3-dimensional printing, fused deposit and modeling in the form of wire, or roll. So these are the different types. Then we have subtractive. So here removal of material generally take place in metals or machining. Additive, addition of material, build parts in layer by layer, slice by slice, as stacking a loaf of bread. So these are the examples. These are the examples of additive manufacturing process. So stereolithography, fused deposition modeling, selective laser sintering, laminated object manufacturing. So first we will start with stereolithography. Stereolithography, that is SLA process. The short form is SLA process. Here we have a diagram of SLA process. We have a chamber or vat is filled with a polymer resin. The polymer resin, the specialty of this polymer resin is a photopolymerization polymer resin. That means when light of suitable wavelength acts or falls on this material, the polymerization of this liquid starts. As a result, it gets solidified or cure, or it can be called photo cured polymer material. So this chamber is filled with photo cured polymer material. Then we can see a platform, movable platform. Then we can see a laser source. It can be moved in X and Y direction. X and Y direction can move in X and Y direction with the help of certain computer controlled or program controlled motors. Here selectively curing a polymer resin layer by layer using UV laser beam happens. Selectively curing. So here the material is photosensitive. Here the build platform is first positioned in the tank of liquid photopolymer at a distance of 1 layer height for the surface of the liquid. So this is placed. This is the platform. This is elevated and this is kept at a distance of 1 layer height. So this much material will be there over the platform. It's 1 layer height or from the surface. UV laser create next layer by selectively curing and solidifying the photopolymer resin. So then UV laser falls on the selective areas and curing to that depth. So the first, this will be the position of the platform, and then it is covered by 1 layer of photosensitive polymer resin. UV light falls selectively, and those area where UV light falls, then polymerization take place, then solidifies. So laser is focused in predetermined path using a set of mirrors. So this controlled by set of mirrors. This process continues so that product part is fully solidified. So after certain solidification, after first layer formation, the platform is moved downward, creating 1 layer of photopolymer over the previously created or previously solidified layer. So this process continues. Finally the entire surface is produced. Here we can see this will be the first layer. This might be the first layer. Then the platform move downward to create this layer. So layer by layer, stereolithographic technique create the prototype. So stereolithography apparatus technology fabricate 3-dimensional solid object from liquid resin. This is photopolymeric resin. It is a material additive manufacturing process. It's additive manufacturing. Computer controlled UV laser draws the image of the object on the surface of the liquid plastic. So it traces selectively. The laser passes and heating the liquid plastic and thereby hardening it. At the completion of each pass, the object would be lowered so that UV laser could go through its next pass. This process continues and the end result is curved out 3D physical model of the object. This process continues and finally we will get the 3D model. In an X-ray electronic motor driven optical scanning mirrors directs the laser beam which cues the borders and cross section of the built part one layer at a time on the surface of the resin. Photopolymers are converted into solid state instantly. Instant conversion to solid state after irradiation of laser beam. The elevator then lowers the newly built layer by a distance of one layer thickness after a short period of time to allow newly formed layer to increase the green strength. So next layer to form a next layer to move down to one layer thickness. The process is repeated until the object is completed and the object is taken out by a resin, raising the elevator, and the object is removed from the vat. That tank filled with the polymers. That is about stereolithographic technique, stereolithographic apparatus SLA technique. Then we are moving to next rapid prototyping technique, that is fused deposition modeling, FDM, fused deposition modeling. It is also an additive manufacturing method by material extrusion. Here it happens as material extrusion instead of polymerization. Here material extrusion is happening here. In FDM, an object is built by selectively depositing melted material in a predetermined path by laser beam. Selectively depositing melted beam in a predetermined path, layer by layer, not by laser beam, by layer by layer. Here we can see a head, extrusion head, which can be moved in X and Y direction with the help of certain programmable motors. Then we can see a spool of thermoplastic material which get melted when it pass through this head, which is a heater head, and this melted material, thermoplastic material, which pass through the nozzle. Okay, so this is the platform, and this create one layer of material. Start from this bottom layer, one layer of material based on the program we give or based on the 3D or model data we given. And then the platform, this process, when it just touches the platform, it gets solidifies to form a solid layer. Then the next layer of material is added to the previous layer. This process continues till the entire prototype is fabricated. So fused deposition modeling is also a rapid prototype technology commonly used to convert CAD drawing into physical part. FDM work on an additive principle, addition process, which extrude material in layers. So here we have extrusion technique we are using, extruding the material through heated extrusion head. Plastic or wax is melted and liquefied in extrusion head through extrusion nozzle. Nozzle is made to move over a trail identified by the CAD design to produce part. This way, single layer is extruded and then is dropped to extrude the next layer on the top of the first until the entire prototype is built with one layer at a time. So this process continues until the entire prototype is built. Material used here is thermoplastic. The spool, here once again, the spool of thermoplastic filament loaded into a roller. Once nozzle has reached desired temperature, filament is fed to the extrusion head and in the nozzle where it melt. The extrusion head is attached to a 3-axis system that allow it to move in XYZ direction. The melted material is deposited layer by layer in predetermined location where it cools and solidifies. So that is about fused deposition modeling. So upon Upon hitting the built platform, liquid solidified and the platform lowers where the next layer of liquid is laid upon it. This process continues until the product is complete. Raw material in this type typically production grade thermoplastic. So sometimes metal is used. Sometimes we use metal also. Next is selective laser sintering or SLS technique. SLS use a powdered polymer build material. Here we use a powdered polymer build material, generally nylon. Here it possesses a powder delivery system or powder bin with a piston and built area. This is the built area, this is the built area and a powder bin. This also with a piston. Okay. First what we do is first we heat powder bin and built area. This powder bin and built area we heat to a certain temperature which below the melting temperature of the polymer. Here the powder bin provided with a blade, it's a cylindrical blade. So it's called it's a rotating blade. It's a rotating blade. Its purpose is to spread a thin layer of powder over the built platform. Here you have built the piston surface will act as the built platform, and this roller is to function is to spread a thin layer of powder over the built platform from this chamber. Okay, so first we heat both the platform with the help of roller. We spread a thin layer of powder material over this piston. This piston is the top position. Fill first layer of material over the piston. Then we have a laser source, generally CO2 laser, then scans the contour of the next layer and selectively sinters the particle of the polymer powder. So once a layer of powder is formed over the piston, using the CO2 laser, it scans the surface, heat it, and due to heating, selective sintering will take place based on the CAD model. Here we can see a manufacturing a component like this. To make this component, first the piston should be at the top position, somewhat here. Then this roller will fill this built platform with powder. Then CO2 laser act upon it with the help of which is driven by program, and which laser act selectively and sintering take place selectively. Selective area based on our design. The area where laser is acting get sintered or solidifies. So when layer is completed, built platform, this platform move downward, and this roller fill the powder material over the previously built surface, and this process continues. So that is about selective laser sintering. So selective laser sintering use principle of sintering. We have studied in powder metallurgy. Sintering is one of the stage in powder metallurgy, where the material after compaction is having a green strength is heated to certain temperature. As a result, bonding will take place. The sintering is a heating process that prevents melting and coherent mass is produced. In SLS, metallic or non-metallic powders are sintered using CAD program guide laser. It's a laser sintered. It's a CAD program guided laser that selectively fuses the powder material. It works with a high powered laser. So CO2 laser we are using. As the laser selectively moves over the surface of the thermoplastic powder, it fuses cross section of the material layer by layer. As one of the layer is completed, the process is repeated by lowering the powder bed and adding fresh layer of material. The first cylinder moves up so that layer the cylinder moves up so that layer of material can be sent to second cylinder by the help of that roller, powder roller. Okay, The second cylinder, after receiving a layer of material, it gets processed using laser beam. Then the second cylinder moves down to receive the next layer from the first cylinder. As it moves up to supply the next layer. So in the powder bin we have a piston that will move up. But at the same time, the piston in the built area will move down. The process continues till final product forms. So that is about selective laser sintering. So it consists of two bin. One is powder bin, another one is built area. Powder bin contain powder, which containing a blade or roller that will act as a filling blade. So by the action of that, the powder gets filled in the built area using CO2 laser. Laser sintering, selective laser sintering take place. This process continue to form till the final layer is sintered. So next is laminated object manufacturing. From the name itself, the object is manufactured from laminated sheet with adhesive coated adhesives. It consists of a material supply roller, then take-up roll, then we have a platform, then we have a laminated roll, that's a heated laminated roll. This is a heated laminated roll, heated laminating roll. Then we have a laser source. Here we are performing laser cutting is happening. Laser cutting is happening. Okay, to remove material we will do some cross cutting also. That's cross layer outline and cross hatching. Okay, so here in it, layer of adhesive coated paper, the paper is laminated paper is adhesive coated. Plastic or metal laminates are successively glued together and cut to shape with a laser cutter. They are glued together layer by layer, they are glued together and then cut with a laser cutter. So main component of this system are a feed mechanism, a heater roller and a laser. The feed mechanism that advances a sheet or a built platform. There's a platform and this feed mechanism, that two rollers advance a sheet or a built platform. The heater roller to supply pressure to bond the sheet to the layer below. So as I said, this adhesive coated paper, by heating it gets cured or it gets adhesive will act. So it gets bonded to the bottom layer. Laser, then we have a laser to cut the outline of the part in each sheet layer. So after the movement of the roller, the sheet get bonded or adhered to the bottom layer. Then we do a cutting using laser cutter based on our program. The part is produced by stacking, layer by layer stacking, then by adhesive action bonding, cutting layers of adhesive coated sheet material on the top of the previous one. A laser cut the outline of the part into each layer. After each cut is completed, the platform lowers by a depth equal to the sheet thickness and another sheet is advanced on the top of the previously deposited layer and the sheet comes into the place. The platform then raises slightly and heater rollers apply pressure to bond the new layer. Heater roller will apply pressure due to heat and pressure. The adhesive will act and get bonded. A laser cuts the outline and process is repeated until the part is completed. After a layer is cut, extra material remain in place to support the part during build. So extra material is removed. So this is another image. You can see two rollers, heater roller, laser source, the platform, this laminated, this is the laminated adhesive coated roll, laminates. So this will be placed, apply heater roller, it get bonded to the bottom layers due to the action of adhesive. Then this laser cutter with the help of mirror, it will cut the contour so that we will get required shape. So that is laminated object manufacturing alone. So process is performed as follows. Sheet is adhered to the substrate with a heater roller. Laser trace the desired dimension of the prototype. Laser crosshatch non-part area to facilitate waste removal. Platform with completed layer moves down out of the way. Fresh sheet of material is rolled into the position. Platform move up into the position to receive next layer. The process is repeated. So that's about some of the techniques of rapid prototyping. So we can have a small revision. We start with the introduction to rapid prototyping. So as we found, rapid prototyping is employed for quick preparation of model or prototype from CAD design. It has certain advantages because after having a design, we can check the effectiveness of the design by fabricating a small model. Because it is cheap, it can be practiced by normal designers. So cost effective, and the material used here can be recycled or reused. So these are certain advantages, and we found there's a comparison between rapid prototyping and normal machining process. We found one is subtractive method, rapid prototyping is additive process, and we found different stages. We prepare CAD model, then STL file, convert to STL file, then slicing, then we build the component using, and then after that post process we perform, like finishing, support removal, etc. We found different rapid prototyping technique like selective laser sintering, fused deposition molding, stereolithography, apparatus SLA, laminated object manufacturing. All are additive manufacturing, that is, we create a single layer, over that we create next layer. This process continues till the entire solid object is formed. So the main advantage is we can make quick production of prototype or physical model of the object, or physical model or prototype of the object can be made from the design and is cost effective. That's about. Thank you for listening.